Good morning. It is Miss Jardine. All right, so we're going to move on with inequalities, taking into consideration everything that we learned yesterday. So first, we're just going to review what we did yesterday. So we're going to take a look at the first inequality. Graph the following inequality. So graphing an inequality means placing that on the number line, putting your circle, deciding in which direction your arrow will point, and deciding if it will be an open or a closed circle. So from yesterday, remember the first step is put a circle at the number that you see. So m is less than 4. So we're going to put a circle around the number 4. Then we're going to look really carefully at our sign. And our sign less than is pointing to the left. So then I'm going to look down here. This sign is pointing to the left. So that means that my line is going to go in this direction. Now, remember from yesterday, we learned that an open circle is if you have only less than or only greater than, which is what we have. So let's say that I'm going to have a birthday party, and my mom tells me that I have to have less than 4 friends invited. You can invite less than 4 friends. Well, I can't invite 4 friends. I can invite 3 friends, 2 friends, 1 friend, or 0 friends. So since 4 is not a solution of the inequality, 4 does not get filled in. The circle is not going to be a closed circle because that would say that 4 is a solution. We want to show that 4 is not a solution. Number 2, what if it said 4 is less than m? So going back up to that first inequality, m is less than 4 compared to 4 is less than m. So I'm going to go ahead and write that other one right above it. M is less than 4. Does that mean the same thing as 4 is less than m? No. So here is a new rule that we're going to learn today. When you're writing an inequality, your variable should always be on the left. So what I can do with this inequality, 4 is less than m, I'm going to flip my m to the left, and I'm going to flip my 4 to the right. But when you flip the variable, you have to flip the sign so that the meaning of that stays consistent. So you could read the first one, 4 is less than m, and now we're going to read this one, m is greater than 4. So no, m is less than 4 does not mean the same thing as 4 is less than m. So now what we've got is m is greater than 4. So now we're going to put an open circle at 4. We're going to look at which direction our arrow is pointing. And greater than points to the right. So we're going to darken all of the values to the right. And that 4 is going to stay open. So let's say that your coach says in order to pitch in the first game, you have to throw at least you have to throw more than 4 strikes at practice. In order to pitch in the season opener, you have to throw more than 4 pitches at practice this week. Well, more than 4 has to be at least 5. So that means your coach is really looking to see 5 or more strikes thrown. So 4 would not be included, so that's going to stay an open circle. All right, let's take a look at number 6. 6 is greater than or equal to x. So remember what I just said about the previous one is that when you're writing an inequality, your variable should always be on the left. So I'm going to rewrite this with my x on the left and my 6 on the right. Now, if that sign was greater than or equal to, I have to flip it. Now it's going to read less than or equal to. So this is what I need to graph. I'm going to put my open circle at 6. I'm going to look carefully to see which direction that arrow is pointing. It's pointing to the left. I'm going to find the matching arrow on my number line. And I'm going to darken all of these values. Now this does say less than or equal to. So since 6 could be a solution to the inequality, I'm going to go ahead and close that circle. So you're having a summer party, you're going to have a pool party, and your mom says you can invite no more than 6 friends. You can invite no more than 6 friends. Well, that means you could invite 6, or 0, or 3, or 1, or 2, or 4, or 5. You can invite no more than 6. That means you cannot invite 7, 8, 9, or 10. So on a graph of an inequality, if you're reading the graph, you can quickly see that 7, 8, 9, and 10 are not solutions because they're not in the darkened part of the line. These numbers down here are the numbers of friends that you can invite to the party. Taking a look at number 4. X is greater than 1 and 5/10. 1 and 5/10. So that's going to be halfway between 1 and 2. So I'm going to put my open circle halfway between 1 and 2. Greater than points to the right. So I'm going to darken all of these values and shade in the arrow. And it's only greater than, it's not greater than or equal to. So I'm finished with that graph. Moving on to number 5. Y is less than negative 1/2. So first I'm going to find negative 1/2 on my number line. Negative 1/2 is halfway between 0 and negative 1. So I'm going to put my open circle. It is not less than or equal to, so it's going to stay open. My arrow is pointing to the left, so these are all of the values that will be included. And we're finished with that one. All right, now we're going to do something a little bit different. Tell whether the given value is a solution of the inequality. So on this page, there are a lot of numbers, variables, equal signs, and it's all a little confused in my brain. So you all know from having me all year that what I like to do is highlight those values first to kind of visually keep that separated in my brain so all these numbers aren't running together. So if that helps you, you can go in and highlight those values in a different color. So if we look at the first one, the question is, if I'm looking at y plus 5 is greater than 7, we're going to substitute 3 for the y. We're going to rewrite that entire inequality. So not y plus 5, but 3 plus 5. Is 3 plus 5 greater than 7? Then you're going to do the math. 8 is greater than 7. And then you're going to tell us yes. Yes or no would be your final answer, but make sure that you substitute for your variable and make sure that you have the math that proves your yes or your no. Okay, going down the page, if y is equal to negative 3, is negative 3 plus 8 greater than 9? So now we're going back to the rules of adding and subtracting integers. Different signs find the difference. 8 minus 3 is 5, and we had more positives, so that would be a positive 5. Is greater than 9? No. Going down the page, 1/2 times b is greater than 5. So we're going to substitute 12 for the b. So is 1/2 times 12 greater than 5? Well, half of 12 is 6. 6 is greater than 5. And your final answer on these is going to be a yes or a no. N divided by 2.5 is greater than or equal to -3. So -5 divided by 2.5 is greater than or equal to -3. Well, -5 divided by 2.5 is -2. Is -2 greater than or equal to -3? Remember, it doesn't have to be both of those. It doesn't have to be greater than and equal to. It's greater than or equal to. Since -2 is greater than -3, our answer on that one is going to be a yes. Moving back over here. X minus 2 is greater than -10 when x equals 2. Substitute for x. X equals 2. Is 2 minus 2 greater than -10? 2 minus 2 is 0. Is 0 greater than -10? Yes. So again, on every problem, make sure you substitute for the variable. Show us the final math that's going to prove yes or no. Is n divided by 6 less than 5 when n equals 12? Is 12 divided by 6 less than 5? 12 divided by 6 is 2. Is 2 less than 5? Yes. Is -1/2 times b greater than 5 when b equals 12? First, substitute for your variable. Is -1/2 times 12 greater than 5? Well, half of 12 is 6, and a negative times a positive is a negative. Is -6 greater than 5? No. Last one. Is 1 minus 2 times p less than or equal to -9 when p equals -5? Is 1 minus 2 times -5 less than or equal to -9? So now we're going to go to order of operations. I've got a -2 times a -5, and that's +10. In front of that, I had a 1 less than or equal to -9. 1 plus 10 is 11. Is 11 less than or equal to -9? No. Last thing we're going to do. Write an inequality for the following word phrase. So this is when you can go back to yesterday's notes when you're working on your practice assignment on Tuesday. Go back to that first page of notes from yesterday. We gave you that little chart at the bottom of the sheet that gave you clue words for to help you figure out which symbol to use. You are in at least 8 of the photos. Keywords there being at least. Your inequalities are always going to start with your x, and the number that you see in the problem is always going to go on the right. Now you need to figure out which symbol you're going to use for at least. Well, at least means it could be 8 or it could be more than 8. So that's going to be greater than or equal to. The temperature is less than -4 degrees. So sometimes the words in the sentence will very clearly tell you which inequality symbol to use. So your x is going to go on the left. The number that you see in the problem is going to go on the right, and it clearly says less than. X is less than -4. More than 3 students from our class are in the dodgeball game. More than 3. Start with your X on the left, put the number on the right, and this one clearly says more than, which means the same as greater than. Number 4, the balance in a yearbook fund is no more than -$5. No more than. Your X is going to go on the left. Your -5 is going to go on the right. Now we have to decide which symbol to use. No more than -5, which means it could be -5 or it could be more than that. Or I'm sorry, could be -5 or it could be less than that if it's no more than. So that's going to be less than or equal to. A number n plus 5 is greater than or equal to -7 9/10. Is greater than or equal to. So this tells me exactly what symbol to use. It is, whoops, sorry about that. Is greater than or equal to. Now this one's going to have a little bit more information in it. A number n plus 5, I'm going to write exactly what it says, is greater than or equal to -7 9/10. Last one. A donut costs $1.25 at Dunkin' Donuts. My total bill was less than $35. Write an inequality that represents the number of donuts that I bought. Use D for donuts. Okay, so I definitely want to use a D for donuts. That's important information. A donut costs $1.25, and my total bill was less than $35. Well, as soon as I see those words less than, I know what symbol to use. Remember when we've been working in class, I said that almost always the total number or the biggest number in the math problem is going to go on the right side of your inequality or your equation. So how many donuts could I purchase at $1.25 each and spend less than $35? So we would multiply the cost of a donut times the unknown number of donuts that I'm going to purchase. So that would be your inequality. $1.25 times the number of donuts is less than $35. Alrighty, so that is it for today. You guys have a good weekend, and we'll see you back on Tuesday. Make sure and email if you have any questions, or join me on Zoom every day at noon. Talk to you later.